This is problem 220 at the end of the chapter. A sprinter starts from rest and accelerates to her maximum speed of 10 meters per second in a distance of 10 meters. So let's draw a v versus t plot for the situation here. V versus t will look something like this. Vertical axis velocity in meters per second, horizontal axis time in seconds. And let's label this one tick up 10 meters per second. And so the profile of the race is going to look something like this. And then if you look at part B, after achieving the 10 meters per second, the remaining part of the race will be run at that constant speed. And so this is T1, this is T2. Okay, part A asks us what the acceleration is, and there's no time information given, so the logical equation to use is the kinematic equation, which does not contain time. That's this guy right here. Vx squared, velocity at some later displacement, is equal to the velocity at the starting displacement. In other words, nothing for us because it's 0 meters per second to begin with, plus 2 times the acceleration times the displacement. So we can solve this equation for A. A is going to be equal to Vx squared minus Vx0 squared over 2 times the displacement. 10 meters per second minus 0 meters per second over 2 times the displacement, 10 meters. Okay, first of all, the units had better be meters per second squared. That's the appropriate unit for acceleration, so I had better get meters per second squared out of this. You can see if we square the top here, we're going to get 100 meters squared over second squared, and the denominator is going to give me 20 meters. So the units are going to be meters squared over second squared divided by meters, which are indeed meters per second squared. 100 divided by 20 is 5. That means that the slope of this line is 5 meters per second squared. Part B asks us to calculate the total time for the sprinter to run the 100 meters, and we're going to do this in terms of calculating, first of all, the first leg, that would be 0 to T1, and the second leg, T1 to T2. So for the first leg, we can look up here and we can realize that the slope of this line is 5 meters per second squared, and so we can write 5 meters per second squared is equal to 10 meters per second over T1 seconds. If you solve that for T1, you'll conclude that T1 is equal to 2 seconds. That's the time for the first leg. Second leg, the runner is running at a constant speed, and there is 90 meters to run. She's running at a speed of 10 meters per second. Meters divided by meters per second gives me seconds, and that's going to give me my time, which is going to be 9 seconds. So the total time is the sum of those two. 2 seconds plus 9 seconds. Total time is 11 seconds.